Okay,
All right.
Okay.
So Friday, we talked about the special right triangle 45, 45, 90, where you told me that my two legs were the same because they were across from a 45-degree angle. Okay, now we're going to look at what we call a 30, 60, 90 triangle. So are any of the sides the same in a 30, 60, 90? No, none of your degrees are the same. So in a 30, 60, 90, depending on where they put the degrees is where your legs are. So in a 30, 60, 90, we've got a small leg. Okay, your small leg goes with your 30-degree angle. We then have a big leg, which goes with your 60-degree angle. And we also have a hypotenuse. Okay, the legs that are associated with each degree are the ones directly across from it. So my 30-degree angle is down here. The side directly across from it is my small leg. My 60-degree angle's up here. Again, the side directly across from it. Now this is my big leg. And across from my 90 is always my hypotenuse. Why do you think my small leg is associated with my 30-degree? Smallest angle. Okay, that's how triangles go. Your smallest side should always be across from your smallest angle. Your middle side or your big leg should always be across from the next biggest angle, and your hypotenuse is always across from your biggest angle. Okay, so look what happens in this one. I've now switched your 30 and 60. So now this is actually my small leg. This is now my big leg. And this is now my hypotenuse. Okay, so again, depending on where they put the angles, changes what legs we have with. Questions? Okay, let's open this up. Let's.
Okay, I think I did this one.
No, you didn't. We're just the whole way on the inside. Remember, we have to go the whole way on the inside. Okay, 30, 60, 90 is not going to be quite as easy as a 45, 45. Okay, because I've got two separate sets of rules for this one. Okay, so first let's identify the sides. So if this is 60 degrees, what does that make this angle? 30. So across from my 30 is 8. So what is this?
Your small leg.
This is my small. That's my small. Across from my 60 is my big. And across from my 90 is my hypotenuse. Okay, you want to base everything off of your small leg. So if you do not have your small leg, that's the first thing I want you to find. Well, we've got that, so we're good. Okay, so we need to go from the small leg to the big leg. So am I getting bigger or smaller?
Bigger.
Bigger. So what's that tell me?
Multiply.
We're going to multiply. And your rule here is we take the small leg times the square root of 3. So your 45, 45, 90 was the square root of 2 was my rule. Here, it's the square root of 3. Well, that's pretty easy. 8 square roots of 3. My big leg is 8 square roots of 3. Okay. We now need to go, because again, I said everything's based off of that small leg. So now I'm going from the small leg to the hypotenuse. Again, am I getting bigger or smaller? Bigger. So we multiply. And your rule to go from the small leg to the hypotenuse is to take the small leg and multiply it by 2.
How do you know it's getting bigger again?
Remember, your triangle. So you've got a 30, 60, 90, and your sides go along with your degrees. So this is your biggest side, your middle side, your smallest side. So if I'm going from the side, we know this is the small leg, we know this is the big leg, and we know this is the hypotenuse. So if I'm going from a smaller angle to a bigger angle and its side, you multiply. Okay? Good question.
Where do you get 2 from?
That's your rules. So your rules with the 30, 60, 90 are the square root of 3 and 2. So just like your 45, 45, 90, everything was based off of the square root of 2. Now we just have 2 different rules this time. And your square root of 3 is with your big leg, and your 2 is with your hypotenuse. So if you want to, on that middle triangle where you see the 30, 60, 90, you can put this is x. So that means this is 2x, and this is x square roots of 3. So you know your rules. Okay. So again, let me do this. So if you go to this middle one, your side that goes with 30 is always x. Your 90-degree side is always 2 times x. And your 60-degree side is always x square roots of 3. So those are your rules. The square root of 3 is associated with your 60. Your 2 is associated with your 90.
Why not the other way around?
Because what's the square root of 3?
Oh, yeah.
It's smaller than 2. So you want your biggest one has to be bigger than everything else. You would multiply by a bigger number. Okay. All right. Example number 2. Example number 2. Again, we need to label my sides. I need small leg, big leg, hypotenuse.
The end is your. Oh wait, I mean the one that's the one from E to W. That's your B. I mean your B.
You said E to W is my big leg. Good.
And N to W is your hypotenuse, and N to E is your small.
Okay. 14 is across from my right angle, which makes it my hypotenuse. E to W is across from my 60-degree angle. That makes me my big leg. And then my small leg is across from my 30-degree. Okay, so this time I start with my hypotenuse. When you start with something other than your small leg, you want to get to your small leg first. So we want to go from hypotenuse to the small leg. Am I getting bigger or smaller?
Small.
Smaller. So we're going to divide. So 14 divided by, what's my rule for the hypotenuse? 2. So we divide by 2. So 7. So my small leg is 7. So now we use my small leg to go to my big leg because there is no rule to go from my hypotenuse to my big leg. which is why I said we have to find the small leg first. So now we're going small leg to big leg. So we're multiplying. We're getting bigger by the square root of 3. So the small leg times the square root of 3, which is 7 square roots of 3. The hardest part about this is going to be memorizing what goes where. Okay. It's not quite as easy where you only have to memorize one little thing with 45, 45, 90. And this is not given to you on your exam. You have no formula sheet.
Oh.
None.
Why don't they give us
Questions.
formula sheets?
No. They do not give you a formula sheet up until you get to your 4th math.
Well, I mean, they should give it to us now.
We're yours.
You don't even get one in math 3. There is no formula sheets.
You got to
You make your own and bring it in.
Yes, you need 4 math credits.
We can?
Oh, I thought that's what she.
Oh,
Right, I
okay.
thought.
You need 4 math credits. And don't make me watch your transcripts because some of y'all, if you don't sign up for pre-cal, I will go change.
Oh my gosh.
You to
man.
freak out.
Please don't say that.
Oh, I will.
No, you're not.
Wow. That's so harsh of you.
I don't care. I don't care. Oh,
I'm taking a screen.
no, you're not.
You can watch
Hot sauce girl. You will take pre-cal.
Definitely taking a screen. Right.
Definitely taking pre-cal.
Taking a screen. All right.
Which one's harder?
Freak out.
I'm definitely taking a screen.
Okay, listen. If you're going to a 4-year college, you need pre-cal.
All right, take a pre-cal.
But
And depending on your major, you probably would benefit from taking calculus before you leave the school. I took calculus my senior year in high school and then took it again my fall semester of my freshman year of college.
well, why would I take it again? Why would I just take a screen? It is.
No, you need pre-cal to do calculus. Okay. All right. Example 3. Let's label our sides.
9-3 is the big one.
Okay, you said 9 square roots of 3 is my big one. My big leg.
The A to C is the hypotenuse.
A to C is my
A to
hypotenuse.
B is smaller.
So that makes this my small leg.
Period.
Okay, again, you didn't start with your small leg. Bye, Jameer. Bye, Jameer. Y.2, Y.3 tonight, friend. Bye, Jameer.
Bye,
We're
Jameer.
videotaping. We'll say bye again at the end of the video. Okay, no,
All right.
we probably won't because we'll forget.
All right.
Okay. So, again, if you don't start with the big leg, the small leg, we must go to the small leg first. So, we're going big leg to small leg, which means we're doing what? Dividing. What's my rule? No. Big leg, small leg relationship. Square root of 3.
So that's
Your roll from your small to your big leg is the square root of 3. So we divide by the square root of 3. Well, what happens in this instance? They cancel out.
so now
Nice and easy. So my small leg is 9.
So then you go from
Small leg to hypotenuse.
bigger
Multiply, we're getting bigger. And what am I multiplying by? 2. So 9 times 2,
It's 18.
18.
Oh my god.
I feel like this is our easiest unit.
No, no.
Wait, please.
Right.
Easy now.
Oh, no.
Try to do it in like 3 days.
I don't want to say that. You're right. And we can't.
I'm not done yet.
Yes.
She said you got me chopped.
No, seriously.
Chop, chop, chop. You all right there, sunshine?
I don't think he is. I'm drinking my water.
I
I'll come get it.
Okay? Sample 4.
The square root of L is hypotenuse.
You said J to L is the hypotenuse.
Yeah. J to K is small leg, and K to L is big leg. Are you sure?
Yeah, Harley.
What's
K to-
that, Harley? Yes.
It even looks like the big leg.
Y'all might help me on that.
It does. Okay. Lolly just said that even looks like the bigger leg. Okay. Wow, this is okay.
It's not at the same time.
Understand.
It's
It's
not
not
always
always going to happen that way. Why? Because they'd like to confuse you.
Like what
You
she
have
did.
got to pay attention to the actual degree because they're going to put on there not drawn to scale.
I hate that.
And you're going to think because it looks bigger that that's your big leg.
You're gonna be like, nope, you're stupid.
Okay. So again, be smarter than the test. Okay, so we start small. So
Or you could say
small leg
the hypotenuse.
to big leg. It doesn't matter. Small to big.
And it's more
Multiply. What's my rule? Square root of 3. We're talking big legs, so we're the square root of 3. So the square root of 3 times the square root of 3, square root of 9, which is 3. Oops, I put that in the wrong spot. My bad. That is not J to L.
Because that's what
That's
I was
K to
thinking.
L.
I was like,
Okay? So when you multiply this time, you get the square root of 3 times the square root of 3, which is the square root of 9. And you know that that reduces to 3. Okay? Small leg to hypotenuse.
You'll multiply by 2, bitch.
Multiply by 2, baby.
I'm dead.
So the square root of 3 times 2.
It's 2 square root of 3.
2 square roots of 3. Whoop, there it is.
You know, got me started, Miss Smith. Woo boy.
Listen, I'm going to be cool like you. You got me chopped.
You got me chopped.
You got me chopped. And I need some water.
You got me chopped.
Anybody got a water bottle? No.
Kinley, you always need some water.
Yes.
You need to
Okay?
something.
Here we go, here we go, here we go, go, go. Go, 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 go. Go, 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 go. 1 on the sides.
So, U to T is your big leg, F to T is your hypotenuse, and F to U is your small leg. F U.
Okay. Big leg, small leg, hypotenuse. Okay. So, they give us the big leg. What's the first thing I got to do? We got to go small. We got to go big leg to small leg. So we must divide. What's my rule? Square root of 3. Oh, geez. You mean I gotta do that whole stupid rationalizing?
No, you sound like you sound like Oliver. Y'all know Oliver.
Oh, no, Oliver.
Yeah, I know.
So we need to rationalize, which means we need to multiply both the top and the bottom by the square root of 3. So we get 12 square roots of 3 over the square root of 9, which we know is 12 square roots of 3 over 3,
Yo, you're going so fast.
Yes.
which, yes, Allie,
Whoa.
4 square
Why do
roots
y'all answer these so
of
fast?
You're going so freaking fast. I can't even write.
Kind of have to.
So,
Me and Harley
Yeah.
have to slow write this book again.
always have to.
square root of 3 is your 16, and 2 is your hypotenuse.
Especially Mr. Kim. Everybody's like,
So here's your square root of 3 and 2.
but
Yes.
You might already said.
No.
How do we know?
No.
Okay, hold on, because Teron's got a question. I can't hear him. How do I know what now?
Which leg it goes with? Like, so So you said beautiful. Big leg, small leg. How do we know that?
Anytime that you're not given the small leg, that's the first thing you want to find. Every time. Because there is no roll that goes from your big leg to your hypotenuse. So you always need to resort back to the small leg to get your rolls to work.
So if it's got the feel in it at all, big leg in it, we divide by
Square root of 3. Anytime you're dealing with the big leg in anything, it's the square root of 3. Anytime you're dealing with the hypotenuse in anything, it's 2.
all right.
This is every day.
So is this if you?
Yeah, Lolly, it is.
Can we go to the next question?
Yes.
I was just asking again.
4 square roots of 3. Okay, I still need to find my hypotenuse. So we've got to go small leg to hypotenuse. Multiply by 2. So 4 square roots of 3 times 2.
8 square roots. of
8 square roots of 3. Remember, you're multiplying. So 4 times 2 is 8.
Yes, but anyways.
All right, last one. Last one.
So
R to U is what? Small?
Dang it, Alfredo, still on fire?
U to C.
No,
No, God. U to E is your hypotenuse, and E to R is your big leg.
See, that's what happens when
No.
Okay, so what's the first thing I need to find?
the body.
Small.
We need to find my small leg. So yes, we are going to divide. We're going from hypotenuse to the small leg. So we're getting smaller. So we divide. And what am I dividing by? 2.
Wait.
Remember, we're dealing with your hypotenuse, not your big leg. Your hypotenuse is always 2. Whether you multiply to get bigger or whether you divide to get smaller, it's always 2. Okay, so 4 square roots of 3 divided by 2. 2 square roots of 3. And that's U to R. Okay, so now that I have my small leg, I need to manage to get to my big leg. Multiply by the square root of 3, because that's my big leg roll. So 2 square roots of 3 times the square root of 3, which is 2 square roots of 9, which is 2 times 3, which is 6. Numero 6.
This goes on 133.
133 is where this one glues.
Who's coming to the spring concert? Me?
What's that?
130 what?
Really?
130. I'm sorry, 134.
That's where it glue in.
Is it 6?
Yeah, 134.
I
My bad.
definitely said I got it.
Oh, see, that shit that was
Do we?
Oh.
Wait, you got me now.
134?
Yes.
Wait, what?
I
Where'd it go?
don't
Give me the paper.
Okay, let's say 9.
Which one? 39.
I was using that as a joke, and I like, make sure you come out Thursday.
Oh, my bad.
Alright, Stormy, can I use your book? Just a lot of money got solo.
What page is it on?
134?
134. Somebody said 133 and I just rolled with it and then realized that it wasn't right.
So it's not on 103?
No, it goes on 134. Okay. On page 135, I want you to leave yourself plenty of space at the top and at the bottom. I want you to fold in these two flaps over top of your triangle and glue it in. Okay. While you're doing this, I'm going to read you the story of SOHCAHTOA.
Cut this out.
You said leave plenty of space at the top.
Over top.
Okay, so I guess
Fold them over top. They can go on top of each other. It's fine. Grab one from over there.
I got gums.
Yo, mama.
My mom got them. I said this morning, so no.
That's why you gotta check her first, man.
I'm just like, I ain't stressed this morning. I'll stay with her.
Okay. So, this story is based on the name of a great North American Indian who became famous for his wonderful problem solving in geometry. In his tribe, they were renamed as adults with a name that represented either their personality or a great event in the tribe for which they were responsible. The young man that we are speaking about was very smart as a boy, but had a very short temper. When things did not go as he planned, he would begin to carry on, throwing, kicking, swearing, a general temper tantrum.
This reminds me of Kevin Warren.
One day in math class, he grew frustrated with the proof that he went into one of his famous temper tantrums and he kicked a huge rock.
Wow.
In kicking the rock, he ended up breaking his big toe. As soon as he broke his toe, he realized how silly his temper tantrums were, and he vowed to never throw a fit again. He became very patient and always used reason to work out his problems. He even became an excellent mathematician. Even the problems that the chief had were sent to him to solve. When he became an adult, the tribe thought long and hard about a name that would reflect his great mathematical abilities. But one wise old woman rose up to suggest that they name him for the event that changed him and made him a better man. To symbolize the dramatic moment in his youth, they named him for a regular event that would continue throughout his life. The constant pain in his foot caused the Native American to spend lots of time at the river, cooling the pain of his forever mangled foot in the river waters. So they named him SOHCAHTOA.
I get it.
Harley, you laugh at anything though, so I mean, like,
Right. I didn't get that first. And it was like I did not get that at first. Oh my god.
All right. Okay. So,
I don't you like cucumbers? Like celery?
She's trying to keep her skin. That's what I'm doing for this boy. And you ain't gonna hurt yourself.
okay. SOHCAHTOA. Okay. This is spelled in a very special way for you to remember how to set up the problem. Here we go. Okay. So it stands for sine, S-I-N-E. Okay. On your calculator, you're going to see this as S-I-N. No, it's not sin. It's sine. They can't fit the whole word on there, so it's S-I-N. It is sine. And if you say sin, I will know what you're talking about. But try to get used to saying sine. In order to use sine to solve, I need to know my opposite side And what do you think H stands for?
Hypotenuse.
Hypotenuse. Hippo.
Oh my goodness. And then you gonna snort
No, I was
with it.
gonna
and
say hip thesis. Thesis.
Hypothesis.
Hip news.
Oh my goodness.
Hypothesis?
Hypnose. Hip
That's all we're gonna write.
Okay.
hyptenuse.
Cosine is ca. COSINE. On the calculator, you will see a button that just says COS. That is your cosine button. In order to solve anything where we need the cosine, I need to know the adjacent side and the hypotenuse. TOA.
Toa. I didn't know it was gonna be like that. I don't know.
Tangent. So in other words, on your calculator, yes, tan. As in, we're not going out and getting a suntan.
Those make me black.
I don't think anyone wants
It
to be
happens.
black.
I don't like that. That's why I don't like summer.
So, tangent, in order to do tangent, I need the opposite and the adjacent.
I'll be dark though. You want-
Okay. You are going to need a pen or something that's not going to erase off of this.
You got big.
Just a regular old pen will write.
I don't know.
Can I use one of your markers?
Oh my god.
I don't know if it'll stay.
Oh, okay.
Hey, have y'all ever
We
seen
can try.
Shrek? Have you ever seen Shrek? When it had the babies.
No.
Is this gonna work?
It should. Okay. Oh, it's gonna erase. Great.
When he was having that drink.
I might have a Sharpie.
It's ugly. Like you're
I'm so much.
Ew, Mom.
Okay.
Shut up.
Shut up. You know what? No, actually, I stopped.
Okay. So, in order to use SOHCAHTOA, we said with Pythagorean theorem, you needed a right angle and you needed to know two sides. Okay. To use SOHCAHTOA, I need two sides and an angle. Okay. SOHCAHTOA is two sides and an angle. Whether one of those sides be an unknown or whether your angle be an unknown, I need two sides and an angle to use SOHCAHTOA. Okay. So you're going to have what we call a reference angle. So on one of your flaps on the clear sheet, I want you to mark this bottom right angle. That word hypotenuse will never change. It's directly across from your 90. Okay. What will change though is your legs. One of them is going to be your opposite. One of them is going to be your adjacent. Think about what the words opposite and adjacent mean.
Opposite will be.
Opposite.
Okay.
And adjacent will be adjacent.
Opposite will be opposite and adjacent will be adjacent.
The same. Is adjacent the same?
Okay.
Oh.
Adjacent is side by side connected to. Okay.
Can I put that as a
Opposite.
definition at the top?
Is across from. Like this. Opposite. Okay, so take a look at your two legs. Which leg is side by side or next to this dot?
Your hypotenuse
The hypotenuse, which we already have labeled,
and the little one.
and this little one down here. Okay, so If my reference angle is down here, that means this side is adjacent.
Oh, I can't write with this marker. You have another Sharpie? I can't write with this marker.
I don't. I've got one.
It's so big.
Just put ADJ or an A. You don't have
It's
to.
like this. I can't. Thank you.
Is that your big ridiculous one?
Yeah,
Your
want
big
it?
ridiculous one.
I do not want it. Why do you have? Oh, that's the big ridiculous. Don't smell them, guys.
Guys, if I need to pass this around later for you guys to mark it back up with a Sharpie, that's fine. Just get it on there for now. Okay.
I wish I would have known.
I spelled adjacent wrong. I put
Okay.
SE.
ADJ, adjacent. Across from that angle is my opposite. Well, I've got another angle on there. So this is why you've got two flaps. Okay? So if you actually open that one up and put your other flap down, this time I'm going to mark this angle at the top. So pay attention to what that does to your adjacent side and your opposite.
It makes that one adjacent and that one opposite.
Right. So depending on where I mark your angle will change your opposite and adjacent sides. So now, because this one is marked, now this side is my adjacent. And my bottom is my opposite.
No.
Actually, this is Y'all are
Okay.
just.
I'm hoping that this foldable helps a little bit more than what I did last semester and last year. Because it's not that y'all don't know how to do this. You have a really hard time between adjacent and opposite, which one's which. Okay. So,
The hypotenuse can never be adjacent or opposite.
no, it's your hypotenuse. It never, ever, ever changes.
Ever, ever.
So we need to start passing this around?
Yes. Yes.
Okay.
Pass it. 835, 135.
Okay.
And I'm not saying it's not hard.
All right. So that is for you to reference. So let's try a couple problems.
On our journal.
Yes, at the bottom. We're going to go clear to the bottom of your page now.
I kind of didn't leave a lot of room down there.
Or if you've got room somewhere on that page. Somewhere on this page, we're going to draw 3 examples. Okay. Somewhere on this page, we're going to draw 3 examples. I don't care where.
You knew better. She knew better.
That's big. That's big.
Okay. So, somewhere on this page, draw yourself this picture. We're going to draw
I only spent $6.
Okay. So, I want you to draw these 3 triangles.
Does that say 23
No.
at the bottom?
No.
22. It doesn't really matter what numbers. We're not actually solving right now. All I want you to be able to do today is I should be able to give you a triangle. You should be able to label the sides. And you should be able to tell me sine, cosine, or tangent. That's all I need you to do today. So, we've got to identify your angle, label the sides that you're given or the sides that you need to solve. and tell me, would I use sine in this situation, cosine, or would I use tangent? Okay. So, your reference angle is always the angle that you do not know that they have a variable or a question mark or something there, and you label your sides accordingly. So, I'm going to zoom in. You can set it on top of my notebook. It's fine. I just want everybody to be able to see what I'm doing here. All right. So, when I zoom in, my reference angle is my unknown. That's what I would need to solve for. So, here's my angle. Okay, so because my angle is what I need to solve for, we are given two sides. Side 27 would be what?
Your hypotenuse.
Your hypotenuse. It's across from your 90. So this is my hypotenuse. 13.
So your big one.
We're not talking small, big leg. We're talking adjacent, opposite, hypotenuse.
Opposite.
Opposite.
Of what?
Okay, that is your
Okay.
opposite. It's across from my reference angle, so that makes this my opposite side.
So if it's always across from the variable, it'll always be opposite.
Yes. Across from your variable or across from your known angle is your opposite. So, which one of my trig functions do I need opposite and hypotenuse?
So
So,
said that. Oh my god.
so this is sine. You would use sine to solve this. Tomorrow I will show you how to solve it. All I want you to be able to do is tell me I've got these, I would use sine. Okay. If we scoochie down, scoochie. Okay, this time, my reference angle, they tell me my reference angle is 30. I need to label my sides according to my reference angle.
So the one that is adjacent to the 90-degree angle, it like on this side by the 26, that is your small leg like that, or doing like that.
But we're not doing small legs.
We're not doing small leg, big leg.
Oh, okay.
Opposite, adjacent, hypotenuse.
X is adjacent, and 26 is opposite.
Wait, what?
So X, we're doing
X is your adjacent.
26 is opposite, and X is hypotenuse.
Yes.
How's your X not your hypotenuse?
So it's not
Hypotenuse.
across from the 90.
What?
Kelly is stupid.
Stop.
Not like that. Not like y'all. Oh, crazy.
Oh, I know it's
Okay, y'all, shut up. I'm like,
So you saying that 30 would be a reference?
Yes, 30 is the angle that you would use. This time you're not trying to find your angle, you're trying to find one of your sides. Okay? So 30 is your reference angle. 30 is what you use to label your sides as opposite, adjacent, hypotenuse. Okay? So across from my 30 is my 26. So that makes this opposite.
what if there were two variables in the triangle? How would you determine which one's your reference?
That's not 30.
It won't be.
No, you will not see that here.
Wait, see what?
Don't worry about it because all it's going to do is confuse you. Okay, we said our hypotenuse is across from my 90-degree. Well, I don't have anything there at all. Not a variable, not a number, nothing. So we don't worry about that. This is my adjacent side. Yes, Kathy.
How would you know to identify a reference term?
Yes.
No, I'm saying no. I would assume it was an X and not 30.
Okay, so
Ew, lovely.
when you're dealing with, that's a great question. When you're dealing with SOHCAHTOA, you're going to see two types of triangles. Okay, they're all going to be right triangles. But you're either going to see triangles with two sides with actual numbers and you're missing an angle, you need to find an angle. Or you're going to see with a missing side and an angle given.
So your missing side will always.
So it's either gonna be the angle you're trying to find as your reference angle, or the angle that you're given will be your reference angle, no matter where they put it.
So we always look for the angle.
So you're always looking for the angle first to be able to label your side. So I could put this as 10. This is my reference.
So the numbers that were given are on the outside.
Those are your side on it.
Angle, you said?
Huh?
It's always an angle.
It's always gonna be an angle. So
So
you're,
Huh?
I mean, they can,
Where's that?
I mean, you already know if this is 90 and this is 10, that makes this 80. So you can use 80 as a reference angle, but then you would use 80 through all your problems. It might make a little bit more sense tomorrow when we actually go to solve. Okay.
Oh, so they just put the numbers on the outside of the spread.
No, the numbers on the outside are the sides. They're the lengths of your sides.
I don't see how you stand up.
So like that's 27 inches long, that's 26 inches long.
So you just don't have to pay attention to them.
You don't have to pay attention to any side or angle that has nothing marked. No variable, no number, no nothing. You can ignore them, okay? Huh? Okay, so Tehran said this one would be tangent.
That's what we call it, period. Yes, ma'am.
Well, because of course I have to give you an example of everything. So yes, the next one will be.
But I was trying to do it, but I was confused.
But what does tangent mean?
Cause like, you know what, fine.
Tangent is the trigonometry symbol that you would use to solve.
Is
We're not
trigonometry
actually
a class?
Yes, they used to teach algebra 1, geometry, algebra 2, trig. Trig used to be its own separate thing. Nope. Okay, so 22 would be my reference angle this time. So that's how I label my sides.
How do you know that it's your reference angle?
Whatever angle they give you or do not, whatever angle they give you a variable or a number in is your reference angle, okay? So 22 is my reference angle. Give me a side. X is my hypotenuse. And 7 is my adjacent. Did you notice that my reference angle always connects my adjacent side to my hypotenuse? Every time. Every time. It's in between your adjacent and your hypotenuse.
Oh, yeah. Will it always be like that?
Always be
Oh,
like
thank
that.
God, that's amazing.
It will always, always, always be like that. Okay, so you would have to use what?
So that, it has to be besides the 90 degrees.
Yes. They have to give you something. You will never use your 90-degree angle as your reference angle. Ever.
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 This is cosine. I also told them last semester, if you take your finger and you cover up your reference angle like this, which side does your finger not touch? The opposite side, every time.
That's crazy. Now,
I don't care which way it makes more sense to you. Your reference angle always connects your hypotenuse and your adjacent. It's always in between the two. So if you're good just labeling your hypotenuse, that'll be real easy to label your adjacent and opposite. And again, if you cover it up, the side that does not touch your finger is always your opposite side.
how can you work
Miss
that?
Smith almost just took my life a couple seconds ago. I'm glad you didn't see it.
Yeah, but judging me.
It's not getting another one.
Okay, I should have.
Okay, you're fine. We're getting into the tabs now.
Is that all right?
So on page 136. Okay. Your sine, cosine, and tangent. What you need to do is fold back along all of the dotted lines. I don't care what order you fold it back in, but you need to fold it back to make yourself some pockets.
Okay, let me stop.
Okay,
It's like-
so once you fold, all you should see is the rectangle with sine, cosine, and tangent. You're then going to glue along those folded parts and put them in your notebook on page 136. I don't care what order they go in, just fit them all on there.
It's the homework.
No, this is the do now work. You've got some IXLs to do
Yes.
Do
on
that.
special right triangles.
Right. Maybe you're wrong.
So do I just glue the tabs down?
Yep. Glue the tabs down because you're gonna have to slide something on the top.
Miss Smith, I need to talk to you once we're done.
She kind of screwed up.
I know, but it's all right. We'll talk about it later.
I'd be like,
Well,
Yes. It'd be so funny.
4, 5.
you do that one more time.
Like he's still recording.
He always does. Why can't we be friends? Why can't we be
because
friends?
people are dumb.
I don't like to talk.
You don't like humans?
What she doing this too? No, she talking to this one.
Can you give me 200 seconds?
No, I can't.
No, no.
I don't know that.
She does too.
Y'all got beef every day.
What's I can do with you?
So, right now, you should be getting 6, no. Pockets each one of these cards go into. What are my sides? Would I use sine, cosine, or tangent? And stick them in the pockets. This is now work. Okay?
Send it out.
When you are finished, IXL Y.2 and Y.3.
That's nice.
Y.2 is going to take you back over 45, 45, 90 triangles and 30, 60, 90 triangles. And Y3 is going to be like this matching activity that you're getting ready to do right now. Where they give you the triangle, you need to tell me sine, cosine, or tangent.
You get it Y.3. You get it because like you still got a point.
Excuse me.
So you like
Okay,